Oh, so the fun of dealing with free software is the fact it has a time limit. So we'll just continue on here. So what was I saying? So you will have a two-parter. Best is to use dimensional analysis. Now I'm just going to make a skeleton here. So remember, anything before the per, and this line means per, remember? Per. It's pretty. Per. So anything before the per goes on top. Anything after the per goes on bottom. You focus on one unit at a time. We're going to focus on miles first. So we need to go to miles to feet. And there's a conversion for that. So we can just go from miles, because it goes to the bottom because we don't want it, to feet. And miles cancel. So we've done our first unit. Now we're going to focus on our second unit. It's on bottom, so it goes to top. We know the conversion that goes from hours to seconds. Cancels, so double check. The only unit left on top is feet. The only unit left on bottom is seconds, so we got what you need. So anytime you're doing a two-parter, focus on one, continue, jump back to the second one, and then you can just continue your line. Now let's go jump back up here and do a couple of examples. Oop, go away. Of the sterile method. So your sterile method is you're just counting steps. So if you have giga, mega, kilo, hecka, deca, base, then you have deci, centa, milli, mu, nano, sorry, no, not nano, and nano's next, but not mu, micro. But I need to spread out these a little bit. So you should have 1, 2 mega, 2 giga, 1, 2 micro, 1, 2 nano. So you're just jumping around with the sterile method. So you put your decimal where you think it is, and you just jump to where you're trying to go. So that's your sterile method. Your dimensional analysis method is very similar to what we did down there. Your exponent method. Now, your exponent method, you have to know your exponents on that go with your prefixes. So make sure you know your exponents that go on your prefixes. Best thing to think about it is it starts out, your base is 0, and it radiates outward. Yeah, but going to the right is negative, going to the left is positive. So it radiates out to -1, -2, -3. We skipped, so that's 4, 5, -6, 7, 8, -9. And again, do it again, it's just positive. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it kind of, your exponents radiate out from the base. So yeah, so that's a good way to memorize your exponents. But from your exponents, let's say you're going from, let's do the meter to milli. So what exponent goes with meter? Remember, meter is your base. So you would just go 0. You always subtract. Always subtract. And you would then -3. So what happens when you have two negatives together? It turns into a positive. So your exponent is 3. Now, you would plug, that is an exponent, and you would plug that into whatever number is here. So let's say this number is 0.003 meters. You're trying to get into millimeters. So then over here, what we would do, we would have 0.003 times 10 to the third. That's done. You're converted. It's officially into millimeters. We would then need to convert it into scientific notation. So 1, 2, 3. We moved it 3 times. And we went from a small number to a big number, so you would subtract that. So our answer would be 3.0 times 10 to the 0 millimeters. So that's an example of how to use your exponents. There we go. So we'll have a two-parter, and then you will have some word problems. We'll have some word problems also. My best hints for the word problems. First, of course, is read the whole problem. Read, apparently. Read whole problem. Before you even do anything, read the whole problem. Okay? Underline your givens. Now, what I mean by givens is underline, does it say you have 15 people come into the party? That would be an important thing to underline. You want to give about 4 slices per person. That'd be an important thing to underline. There's 12 slices in one pizza. It's an important thing to underline. One pizza costs $14.78. That'd be an important thing to underline. So underline your givens. Then circle what you're looking for. Then circle what you're looking for. Make sure what you're looking for is always on top. So, circle what's always on top. So let's go back to the pizza problem. So we had 15 people, right? So that was our first given. So we're just going to throw it up here, 15 people. But remember, our circle was wants to know money. So we need to make sure our money ends up on top. But we don't want people, right? So people we know needs to go to the bottom. Do we have anything within our givens that's connected to people? Well, we have person. Yeah, same thing. So for one person, we want 4 slices. So people cancel. We don't want slices, we want money. We're getting there. But so slices need to go where? Yes, to the bottom. So if we read, for one pizza, we look back at our underline. So for one pizza, takes up 12 slices. Slices cancel. We don't want pizza, we want money. Let's keep going. Oh, but we do know that for one pizza goes on the bottom because we want it to cancel. It's, I believe, $14.78. Get a pizza. Dollars is on top? Do we have any other units? Nope. Awesome. So just multiply across the top, multiply across the bottom, and divide. Make sure you put your answer into scientific notation. Make sure you do that. Okay? Make sure you put your answer in scientific notation. That's about all the hints I have. Again, I have one other hint. our test is about